All right, hey gang. Here's what I'm going to do. I'm going to start to walk you through the next section here. Again, it's a review of what we've already talked about, and I just want to continue to reinforce the rules that we've already established. Okay. On this first page, if you can't see at the top of my paper here, you can reference page 141. All the rules are found there, and what you'll see is a list of the rules. And as we probably talked in class, some of the rules seem very similar to each other, so I'm not going to be super nitpicky about that. As long as you have the right idea, you're trying to match the right concept, the right picture components with the right postulate, I'm completely fine with that. Okay, so don't get overly anxious about, is this the exact right one? Well, it's very similar to this other one. I'm not going to be super picky about that. Okay, we may talk about why one is probably more correct than the other, but again, don't get too wrapped up in the details right there. So as I look at number 2, we're going to get right into number 2. If I go down through page 141, it says line P lies in plane N. So this line right here, line P, is in this plane right here. It's also in plane M. Okay, it's the intersection of both planes, but a portion of it is in plane N. Actually, all of it's in plane N and all of it's in plane M at the same time. So what I'm going to do is I look down through my notes through page 141. I guess the postulate that sticks out to me is 2,5. Okay, and 2,5 reads this: if 2 points, sorry, I probably should get this off so don't have to look at me. If 2 points lie in a plane, then the entire line containing those points lies in that plane. Okay, so if you look here, actually this would be 3 points, but it says if 2 points, because we only need 2 points to identify a line. And so we've got 3 points, they lie in plane N, they also lie in plane M, and so the entire line P also lies in plane N. Okay. I'm going to drop down to the next section here, and I know students always see these always, sometimes, or never. I think every math class has them, and they're hard because you really have to analyze and think about your response. So as I look at this, it says a plane contains at least 3 lines. Okay, so what I'm going to do is I'm going to draw 3 lines. Now you can draw them parallel to each other if you wanted to, and we would still get this idea across, but I think the best picture would be something like this. Okay, and what you're going to notice here when you draw these 3 lines and they're intersecting, we have at least 3 points. Okay, and so when I think about this, these 3 points are non-collinear. Okay, and so as a result, what we end up having is this. If we know that we have 3 non-collinear points that make one plane, and I'm going to jot that down, 3 non-collinear points equal one plane. Okay. We also know that 3 non-collinear points can form 3 lines. And so as a result, does every plane have at least 3 lines? The answer is yes. If you have 3 points that are non-collinear, you're going to end up having 3 lines. Okay. Now, do they have to have those lines? No, but the possibility of having those lines is always there. So I'm going to say always for that one. Okay, it's always going to be true that 3 lines can exist to form a plane. Okay. Dropping down to the next one, in the figure, DG, D, and DP are in plane J, and H lies in DG, on line DG. Okay, so there's H on line DG. State the postulate that can be used to show that each statement is true. Okay, so G and P are collinear. G and P are collinear. Now there's no line there, but between any 2 points there is exactly one line. So there could be. Okay, there isn't one right now, but there can be. So I'm going to probably do 2.1 through any 2 points. There is exactly one line. Okay? Through any 2 points, there is exactly one line. Okay? All right, now, from here, I'm going to take a look at this right here. Okay? This next one, I'm not going to have you write out, number 8. It is a proof, and it's actually going to be a paragraph proof. So what is a paragraph proof? A paragraph proof is basically writing a story that tells why something is true, okay, in paragraph format. I mean, when we do a 2-column proof or a flow proof, you don't use the connecting words like therefore, because of this, we then know, stuff like that, okay? It's just there, and you just know the flow of the proof, and you can, but if you are a person that wants to be maybe in law someday, and you want to write laws, or if you want to be a lawyer, and so to actually prove something, you're going to be writing paragraph proofs and multiple page paragraph proofs, and maybe booklets, hundreds of pages of a proof, okay? And so here's what we have for this one. In the figure at the right, point B is the midpoint of AC, and point C is the midpoint of BD. Write a paragraph proof to prove AB is equal to CD, okay? Now here's what I want you to know. You do not have to write all this out, okay? I just want you to pay attention and listen and see the flow of a paragraph proof. So when you do a paragraph proof, we want to start with the individual given parts. So if point B is the midpoint of AC, that should be a segment, not a line, then AB is congruent to BC. Okay, so these are going to be equal by the definition of midpoint, which again means to be equidistant from the endpoints, okay? Now the second part of the given is this. If point C is the midpoint of BD, then BC is congruent to CD by the definition of midpoint. Okay. Now, as you can tell, all of these are congruent here. So I'm going to go ahead and say something like this. If AB is congruent to BC and BC is congruent to CD, then AB is congruent to, I should have done that on the other line, then AB will be congruent to CD by, think about it for a second, see what property we've used there, okay? If A is congruent to B and B is congruent to C, then A is congruent to C, right? By the transitive property of congruence. Okay, so again, you don't have to write this out. I just want to make sure that you see how to set up a paragraph proof, okay? Now, we're not done yet because we had to prove AB is equal to CD. Well, you say it's the same thing. I view it the same thing as well, but we want to finish this up. So I'll just say something like this. Since AB is congruent to CD, we then know AB equals CD by the definition of congruence. Okay, so again, you didn't have to write all that out. I just wanted to walk you through. Hopefully that all made sense to you as I set that in play. But again, that's a paragraph proof. Okay, it's a lot of writing. I don't like doing paragraph proofs as much. Two-column proofs are much easier. Same thing with flow proofs. You just kind of fill in what's missing and you go. Okay. All right. As I go to the next page, all the properties that we're using here are listed on page 143. Okay. Usually this takes no more than like 5 minutes to do this. You just have to work through each part and look at the properties or try to find the properties. So as I look at number 13, in years past, I've noticed that this is one that gives people difficulty. It says we want to use the division property of equality. If 4 times the measure of angle QWR is 120, then what would the end result be? Well, if we're using the division property of equality, I'm going to divide both sides by something. Think of this as 4x equals 120, and we want to get x by itself. So this is the measure of angle QWR would equal 30 degrees, okay? So that's really all it is. It's not that complicated there. Division property of equality. This one down here, name the property that justifies each statement. I'm going to go ahead and do this. If angle G, the measure of angle G is 35, and the measure of angle S is 35, then angle G is equal to angle S. I'm going to say something like this. If A equals B and C equals B, then A equals C, okay? So I would do the transitive property. Or you could also put substitution. Since both of these equal the same thing, we can substitute one in for the other, so angle S equals angle G. So substitution would be fine with me there too. Okay, I think transitive is the better of the two, but what is transitive? It's a form of substitution. Okay. All right. With that being said, the last part of your homework assignment is right here, and it says Blake and Katrina were asked to write a flow proof for the following. Is either of them correct? So maybe neither is correct, maybe one is correct, or maybe both are correct. And so I want you to go ahead and tell me what your belief is down here. Just a couple sentences. I believe this to be true because of this and this, and that's good for me. So, hey, I appreciate you paying attention for the last couple minutes. I know that was a little bit longer than I had anticipated, but hopefully that is helpful as you work through the rest of your worksheet there. Thank you. Have a good night, and we'll see you next time in class.